Today, scientific notation, kind of using the rules that we've been talking about the past couple days. But first of all, what the heck is scientific notation? I haven't done total research on this, but here's what I've always assumed. In science, they do all kinds of calculations, and they get extremely large numbers sometimes, and they get extremely tiny numbers sometimes. You know, it's just like, it was like, how far is it from here to the moon? Big number, you know what I mean? That kind of stuff. So really, really big numbers, really, really small numbers. They didn't like all these zeros for sure. They just don't like writing all those long numbers out. So they have changed it to a different form where what's kind of weird is this is actually a number right here. This, I know it's a letter A, but it's just a variable saying, hey, to be in proper scientific notation, like it's going to be some number times 10 to a power. Why times 10? Because that's what all of these like decimal places are worth. You've got your tenths and your hundredths and your thousandths, and I think you know most of the world uses the metric system as compared to the U.S., which doesn't. You know, so it's that power of 10 thing. But here's the real kicker: to be in proper scientific notation, this number A has to be between 1 and 10. It can be 1, but it has to be less than 10, and we'll deal with that as we go. So first, let's just kind of do this. Let's take these normal numbers and put them in scientific notation. You see, this guy is really, 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 really big, right? So here's what I got to do. I got to squeeze this down to where I'm looking at all these numbers, and like, would you believe that if I tried to turn it into a 51, you know, like a 51 doesn't fit this criteria. It's not between 1 and 10. I'm always going to say between 1 and 10. Realize 1 counts, but 10 doesn't count. I can't make 51 fit between 1 and 10, so wouldn't I have to squeeze it to 5.1? Question, is 5.1 between 1 and 10, yes or no? Then we put this times 10 to the, and here's what you got to do. You kind of got to count, like, how many places did you move the decimal? Are you cool that the decimal really was, like, right there, you know? Didn't we move him 1, 2, 3, 4, 5, 6 places? Isn't that how many times we've moved it? So that's why that's going to be times 10 to the 6th. Every time you move a decimal, it's another power of 10 in that case, like 10, 100, 1,000, so that's why that's all that way. So let's try this one right here again. I'm just going to realize where all the zeros kind of start. I know there's a 0 right in there, but you agree that all those pink guys are zeros. I'm trying to get rid of those. So to take this guy right here in red, which is not a highlighter, Mr. Farnstill, but in green right here, and squeeze him to where he's between 1 and 10, it can't be 803. It's got to be 8.03. Are you kind of with me on that? How I just kind of squeezed it to where it's between 1 and 10. And then I count how many places I moved the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different places. Are you with me on that? I moved it 10 places, so that's times 10 to the 10th. Let's do one more kind of together before I really turn you loose here. Forget about all the zeros, right? Don't care about any of those guys. I'm looking at this orange number, this 1425. I need to squeeze him to where he's between 1 and 10. What would that squeeze down to? 1.425. Are we okay with that? Right, 1.425. And then times 10 to the, and let's see here. Are we cool with the fact that every comma is 3 decimal places, right? So if you wanted to go, okay, there's 3, there's 6, and then it moved one more spot, so there's 7 times 10 to the 7th. Here will be an interesting thing of how you have to type this into the computer, because in scientific notation, I'm a fan of using this for a multiplication symbol, the old school X, you know what I mean? The computer don't like that. That looks at it as the variable x. Are you with me on that? So it'll even tell you on there, you'll have to type it like this, 1.425, and then use the asterisk, you know, like instead of that, times 10 to the 7th. But here's the crazy thing. If you like totally use your calculator, sorry I didn't have my calculator open, they don't use that notation either. You'll see this decimal like this, like 1.425, and then you'll see like this weird E7. And that E on calculators means times 10 to the. Some of the little calculators still put the times 10 to the, but most of the larger TI calculators use a big capital E for scientific notation. So it's really, 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 really weird. Cool. Let's squeeze this guy. See all these zeros? Like once all the zeros start, want to kind of get rid of them. Squeeze him, and then see what the times 10 would be. Times 10 to the 3, 6, 9, 12, 13 is what I got. Is that okay? And then do this one again. Why doesn't this work on number 5? Sorry, I'm getting a little too fast. I'll let you try number 5. But I have a wrong answer on number 5. Why didn't that work? Go ahead. That first number, that quote-unquote A number, isn't between 1 and 10, right? You know, so it's got to be 1.4 times 10 to the 4th. And then try one more of those dudes. Get rid of all those zeros. What an ugly one this guy is. 3, 6, 9, 10, 11 is what I got. We cool with taking a normal number, which is called standard form. That is how our standard numbers go, and putting it in scientific notation. Cool. Now let's reverse it, right? They give us a guy in scientific notation. They want us to put it in standard form. This is the key, baby. Bing! That's how many places you need to move the decimal. We need to move that decimal 4 places. So if I do it, I would have a 4. And then 1, 2, 3, 4. Holy cow, guess what we're going to put in those 2 spots that there was nothing there? What did we get rid of back here that was like something that took up all those spaces? We're going to put zeros, right? Zeros. So this would be 4, 9, 1, and then you need 2 more zeros, right? Because we had 2 decimal places already, and we needed 4, so we needed 2 zeros in that spot. That was a positive 4. Didn't I move the decimal to the right in that case? When you have a negative exponent, by the way, the only time negative exponents are actually allowed is in scientific notation. You know, like what we did before, like yesterday, was not scientific notation. So yes, you can have negative exponents in scientific notation, but this means move the decimal 5 places, but not to the right, to the left in that case. So he's right here, and then I've got 1 spot right there, and then don't I need 4 more? So doesn't that tell you you need 4 zeros to start this guy off? And that's that really, really small number. You know, everything up to this point has been really, really big numbers, you know. In scientific notation, sometimes they have really, really small numbers as well. So one more. Which way should I move the decimal on number 9? To the right or to the left? To the right. How many zeros will I need? I need to move it 8 spots. I got 2 decimal places already. How many zeros do I need? 6. So I literally just write 603. Then I go 1, 2, 3. 4, 5, 6. Are you with me on that? I just kind of count how many zeros. And then, hey, I got a huge pet peeve. I should have done it even on number 7. I got a little ahead of myself. You got to go backwards and put commas. Like, I don't know what happened in elementary school the past, like, 10 years, but they've just gotten kids to not put commas in large numbers. All large numbers that are more than 4 places. Like, I don't care about this. Like, to me, that I can read that as 5,280. But if you have a 5th number, you should put a comma in it to make it easier for people to read. Does that sound okay? So once you get 5 numbers, let's put that in there. Cool. Last one that I'll help you with. Which way should I move the decimal on number 10? To the left or to the right? To the left. So I need 5 zeros. 3, 4, 5. And then 2, 0, 0, 1. You don't put any commas when it's really, really tiny. You only put the commas when it's really, really large, right? So that's just a tough one. Would you believe that is a very tough number to even realize what it is? You know, it's just really, really tiny. Try 11. Try 12. 1, 0, 0, 0, 2, 4. That was 1, 2, 3, 4, 5 spots. I need 10 spots to the right, so I need 5 more zeros. 1, 2, 3, 4, 5. Then go back every 3 spaces and put yourself some commas. And now, if you're kind of trained with numbers, I can look at that pretty easy and go, okay, that's like 10 trillion something or other. You know, you got millions and billions and trillions. The commas made that pretty easy for me to see I was in the trillions category. And then here's the strangest one of them all. Like just 5, right? You know, it's like it doesn't have the decimal for us. We have to move the decimal 5 places to the right. So the decimal really is like right there. You know what I'm saying? It's 5.0. So 5 places to the right means you need 5 zeros. 1, 2, 3, 4, 5. Boom, 500,000. We're cool with the basics of scientific notation, you know. Have you seen that before, just out of curiosity? I can't remember. Okay, good. So I didn't know if you'd done that before in the past. Here's the more challenging part, maybe the stuff you have not seen, is multiplying stuff together in scientific notation. We get to use our exponent rules that we've learned about the first 2 chapters. And it's simple. If I had this 3x squared times 2x to the 5th, how would you multiply those together? What would you do? Would you do 3 times 2? Yes or no? And get 6. You take the numbers times the numbers, and then x to the 2nd times x to the 5th. What would you do with those exponents? Add them or multiply them? Add them. Isn't that totally 6x to the 7th? You do the same thing here. These are our coefficients. Let's grab our calculator and do some multiplying. I want to take 3.4 times 5. And I got 17, right? Then that would be times 10 to the, aren't both of these guys with base 10? You know, just like both of these guys were with base x, right? You know, if they're both base 10, I can add those exponents together. And last I checked, 3 plus 4 is 7. Are we cool with me getting times 10 to the 7th? That is almost correct. Why is that not in scientific notation properly? Close, but no cigar. Tell your neighbor why not. So it's about this guy right here. What's wrong with him? He's not between 1 and 10, right? You can be 1, you can't be 10. You have to be less than 10. So what I got to do is squeeze him. I got to turn him into a 1.7. And then here's what's going to happen. We're advanced, so I think you can handle my shortcut right away. If you see that little pink 7th power, he's going to have to change. And here's how it works to keep it balanced. What did we do to 17? Did we make him bigger or smaller? We made him smaller, are you with me, by a power of 10. That means this 7 has to get bigger, right, to keep things balanced. How many places did we move the decimal, by the way? 1 place. So this has to get bigger by 1 power of 10. Are you with me on that? So instead of 10 to the 7th, it would be 10 to the 8th. And by the way, I do want to see all those steps, right? I want to see it the first, you just multiply it together. You may or may not get a good answer, right? And then when you clean it up, we get that guy. Cool? They say put it in both forms. This is in scientific notation. Now let's put them in standard form, so let's rock with that. Don't I need to move that decimal 8 places to the right, right? So I would have 7 zeros. 1, 7, and then 1, 2, 3, 4, 5, 6, 7. Boom, boom. 170 million is what that guy turns out to be. So let's try that again. Let's multiply these guys together. Number times number. Just punch them in. 2.8 times 1.9. And I got 5.32. Then I'll have times 10 to the, what am I supposed to do with these exponents right here when it's like when I'm multiplying those together? Add them up. A negative 4 plus 7 is how much? 3. And then here's the question that you got to ask yourself. Is that proper scientific notation? AKA, that number right there, is he between 1 and 10? Yes. So we're good. That is scientific notation. Let's put him in standard form by moving this guy 3 places to the right. So 5, 3, 2, and then I need 1 0 back on that guy. What a weird thing. That is 5,320. Cool. Let's try that again. Number times number. Boom, boom. 6.7 times, was it 3? Is that what it was? Thank you. 20.1 times 10 to the negative 7 plus 3 is negative 4. Talk to yourself. Is that good for scientific notation? Nope. So this bad boy needs to squeeze to be between 1 and 10. So how about 2.01? Cool. And then here's how I talk to myself through it. It gets a little tricky with these negative exponents, right? This 20.1 What did I do to make him 2.01? Did he get bigger or smaller? I made him smaller, right? By how many powers of 10? It's how many places you move the decimal, right? One time, right? So this guy has to get bigger. Are you with me on that? So the hard part is he is a -4. What is 1 bigger than -4? -3, right? So watch that. Brain fart is what I call it. I think everybody gets it, but sometimes we accidentally go -5, you know, because our brain just wasn't locked in. Cool? So, all right, let's try another one. 8.1 times 2.3. Ooh, 18.63 times 10 to the what? Second. I'm going to change it. I'm going to just make something up because we haven't had any of these. I want to make sure that we're good. So, like, instead of doing this problem, I'm just going to make up a whole different problem. Sound okay? So just cross this crap out. Just cross it all out. And what if you had this? 322.5 times 10 to the 4th. What if you did a bunch of multiplying and you turned out to get that, right? Is that in proper scientific notation? What do you think? Nope. This red 322.5, way too big. So we got to squeeze him to be between 1 and 10. Are you with me on that? What would he squeeze to? 3.225. Then, are we cool with the fact that we made him smaller, right, to get down there? The other guy has to get bigger, but how many places did I move the decimal? I moved him 2 places, so this 4 has to get 2 bigger. Are you with me on that? He has to get 2 bigger and become a 6. So it's all about multiply them together, right? See what number you get. Then make sure you squeeze in between 1 and 10. How many places did you move the decimal? Do the reverse effect to that guy. Sound okay? And then the last thing, I bet you figured out just what you can do. It's like dividing instead, right? So what's weird is we may not know how to do the exponent part because I've cheated and played like change of house game, right? So we have to do the real rules. But what we do with these is literally what it says. Back here, didn't we totally multiply those guys together? Because that's what they told us to do. We will divide these. So let's do it. 4.9 divided by 2.5. And I got 1.96. Did you get that? Now here's what the real rules for quotient of power says, is you're supposed to subtract those exponents from each other. Just like if you did this, x squared, let me do an easier one. If I did x to the 5th over x to the 2nd, you're supposed to subtract those exponents from each other, and you always take the top one minus the bottom one. Are you with me on that? So isn't that really x to the 5 minus 2 is how much? 3. That works out really nice when there's more x's upstairs than there are downstairs. But if you had x to the 3rd over x to the 4th, you're supposed to subtract those exponents from each other and get x to the negative 1st. But you can't have negative exponents. So you're supposed to reciprocate the base, and it turns into 1 over x. So it's just a long, long story. But what I'm trying to tell you here is you really can't play where are there more with this scientific notation stuff. We need to do the real rule of subtract that orange guy minus that green guy. And here's where it runs into some problems. It's a -3. I'm going to write it down. It's a -3 minus a -4. And what does a minus turn into, baby? Plus, right? So what does -3 minus a -4 turn out to be? AKA plus. What is our exponent on that going to be? 1. That's weird. So let's do a slow recap. Where did this number come from? Dividing. Right? 4.9 divided by 2.5. You'll need your times 10 to the for the scientific notation crap, right? And then what do you do here? Subtract top boy, -3, minus a -4, and I got a +1 back on that one. Is he in good scientific notation? Yes, because this is between 1 and 10. Now let's put him in standard form as well. So I need to move this decimal how many places? Just 1. That would become 19.6. All right, so Are we okay with that? That's weird. It's still a decimal. That's okay, you know. 19.6. Weird. Let's try that again. Coefficients. Divide them. 5.8 divided by 5. And I got 1.16. Did you also get 1.16? Then I'm going to do times 10 to the. Talk to your neighbor about what this should be. You need to subtract those exponents from each other. 4 minus a minus 2. Minus a minus is a plus. So what's it got to be? To the 6th. Are you with me on that? 4 minus minus 2, right? So weird. Then let's put that. Let's go with 4 zeros. 1, 2, 3, 4. Yeah. Here we go. This is the one I'm looking for right here. Sorry, I have a little bit of a math brain. Let's do this next one. Let's divide our coefficients. 1.6 divided by 4. And I get 0.4 times 10 to the. Subtract those exponents from each other, baby. Top one minus the bottom one. How much? 9. Hey, it doesn't happen that this one's always negative down here. It could be a positive guy. It just so happens in all my examples I put it that way just so we get better at them. But if this was a positive 4, you know, you'd have just a 1 down there. You know, you're just subtracting the exponents. Here's the question I have for you. Is this in proper scientific notation? Isn't this number right here supposed to be between 1 and 10? He's too small. So don't we have to make him bigger? Right? You know, we got to make him bigger. So we'll move that decimal. Instead of 0.4, I'm going to move him this way and make him 4. Are you with me on that? Times 10 to the, and if this number right here gets, if this number right here gets bigger, what does this number right here have to get to keep us balanced? Smaller. By how many places I moved the decimal? Didn't I move him 1 place, right? So he's got to get 1 smaller. So how about an 8, right? That number in front has to be between 1 and 10. And then standard form, 1, 2, 3, 4, 5, 6, 7, 8 zeros. 400 million. Try number 20. Number 20. I divided the 8.6 by 1.6 and got 5.375. Subtracting these exponents from each other, I got 6 minus a minus 3. And I got a 9 out of that. What do you think? Silly, weird scientific notation. Do a lot of crazy experiments with really, really big numbers and really, really small numbers. They like to kind of shrink them down to scientific notation. Be careful of what homework's asking for you. This guy's called scientific notation because he's got the times 10 to the. This guy's called standard form. Are you with me on that? Again, typing it in, do what they tell you to do. You'll probably end up using an asterisk there instead of an X. Okie dokie. Let's do some homework.